there are a couple of very specific features on which you can be asked a short note of 10 or 12 marks, and some of those features, like they can ask you exclusively on moors, the mid-ocean ridges, in particular maybe Atlantic moor. They can ask you a question or a short note on the back arc basins, the parts of the oceanic collision margins. And another one that they have asked on is submarine canyons. So while you're preparing for ocean bottom relief, make sure some of the specific features are well prepared. So because I think can handle more and the margins like the back arc basins, or maybe I'll take up a video sometime later. For now, I'm focusing on submarine canyons. So typically your answer must have these 3 or 4 sections. Describe what submarine canyons are. Essentially very deep, elongated depressions along the edges of the shelf right through the slope up to the ocean floor. So they are like deep valleys carved on the shelf edge and along the slope, and at the bottom of which a lot of sediments accumulate here, and these sediments ultimately become part of the transition zone called as the rise. So a short discussion about what is it, what does it look like. Then move on towards some examples. We have Montgomery Canyon, we have the Hudson Canyon, we have River Amoor Canyon, we have the Indus Canyon, and on a map of the world or a map of a specific ocean, show us some of them. Okay, you have with a description, you have a diagram, 6-7 examples, and plot them where you can on the world map. Then you move on towards the theories about how the submarine canyons must have formed. So your book has 4 of them, but I will focus on 3 of them. We have the Diastrophic Theory given by 4 or 5 people. The 2 more famous names are Lawson and Yanasaki. Then we have subaerial erosion theory. Again, a lot of names, but the more popular ones are Dana and Shufford. And the more recent, which is more accepted also, is the turbidity theory given by Davis, Daly, and supported by Buchanan. So know these names. I'll help you read through the book also. So these are the 3 theories. So quickly let me describe this for you. The diastrophic theory is about that the canyons are tectonic in origin, the consequence of some endogenic processes of bending, rifting. So they are something like rift valleys. But the problem with this is that if this was a rift valley, okay, common sense tells us the rifting should have been lateral, not along the slope. Why? Because if this was the floor that ultimately turned and became a basin, the cracks should have been lateral. The cracks should have been along the coastal orientation rather than across. So this theory has that problem. Subaerial erosion says that this is erosion by rivers and glaciers, as this is where the rivers and glaciers terminate, and they start eroding and they carve out a deep valley like a canyon. The problem with this theory is that if I go by the Davis model, it's impossible for a glacier or a river to erode below the base level. So if this is the base level, the sea level, below the sea level, it's impossible for these agencies to erode. And the possibility of marine water level change is ruled out by because the canyons exist right up to the floor of the ocean. To say that the entire ocean floor was exposed and the river eroded, that sounds a bit too exaggerated. So the erosion theory was not accepted. And the third one is the theory which is about erosion by turbidity currents. Now, just a quick reference to what these are. Now, these are enormous amount of sediments brought by the rivers and glaciers that pile up on the shelf, and these sediments, they fall along the slope like underwater avalanches. So there is a relationship between the rivers and the canyon formation. But remember, the rivers themselves don't erode. The rivers bring sediments. They deposit on the shelves. And over millions of years, as the sediments accumulate, they are pushed towards the edges, and when they fall as underwater landslides, when they fall as underwater avalanche of sediments, they scour out, they dig out sediments, and you can find the sediments ultimately on the ocean floor. And these sediments don't flow. They are not examples of solifluction. They are not like soil creep, which are slow, gradual, gentle, and continuous. This sediment flow is not like that. These are enormous ones that fall through sudden jerks. So you compare a mud flow with a landslide. So this is something like a landslide. And we call those as turbidity currents. So modern theories accept, the more modern interpretations accept this turbidity current as the most likely process that must have scooped out the deep depression along the shelves and the slopes. In many of the oceans and river mouth, these canyons, they get covered also, until a time when the sediments ultimately fall off and clear it. So we don't have such a remarkable canyon along the Ganga mouth like we have along Indus mouth. Why? Because in many places, I said, the sediments kind of cover them up. So that's more or less what are canyons, examples with maps, and the three explanations. And you may conclude the answer by mentioning how they're a significant part of the ocean margin topography, how they're a significant part of understanding how the ocean floor has lot of terrestrial deposits. So you can link these currents and deposits with the terrigenous deposits that are carried and ultimately accumulate on the ocean floor. So we have got different type of muds that accumulate here. So the concept itself, you can link it with something about the deposits and the distribution. So if I quickly run you through the textbook, again, Oceanography by Savindra Singh. This topic is taken up on page number 65. Submarine Canyons, second column. It says, they are long, narrow, very deep valleys like trenches, and trenches is not the right expression, like trenches located on the shelves and slopes of the vertical walls, resembling continental canyons, and are called as submarine canyons. So they may be glacially eroded, the deposits brought by the glaciers, or they may be non-glacial. But remember, the glacier itself doesn't erode. Why? Because it can't erode below the sea level. Then we have a small discussion on page 66. The first paragraph, it says, on average, there's a little difference between the transverse and the longitudinal profile of submarine canyons. So if you take a cross section like this and like this, so Shefford talks about that. You can look this up, not an issue here. Then it talks about examples. You can look up the page 67. So pick up 3-4 of them. These canyons along the east coast of India, Cuddalore Canyon, Pondicherry Canyon, Palar Canyon. We do have Ganga Canyon, but it is not really as prominent. Why? It is covered by some deposits. Apart from these, we have some canyons across the world. So page 67, if you look at distribution of canyons, second column it says, they found along the east coast of US, from Canada to Cape Hatteras, along Mediterranean, Californian, Mexican. And page 68 has some examples: Hudson Canyon, Chesapeake Canyon, Mississippi Canyon, Cape Breton Canyon. We have canyons of Pacific Ocean. So pick up 4 or 5 of them. You could actually make a table here. That'll be a good way of depicting when you have got too many facts to correlate. So name of the canyon, and maybe the ocean name, and maybe the river's name. Mouth of which river do we have it? And then the origin. Page 68. Okay. Origin first is diastrophic theory. It talks about folding, faulting, warping. They consider the canyon as a fault, as a rift, a graben because of some tectonic processes. Okay. Then there are some debates against this. The next is the subaerial erosion given by Dana and Shefford, that they are the consequence of river valleys by running a river and drowning of these valleys. But the problem with this, I said, page 69, first column, second paragraph, it says, first column, second paragraph, page 69. W.M. Davis, while contradicting the above theory, argued that the formation of submarine canyons through subaerial erosion required vertical oscillation of land, say upheaval of margins up to thousands of feet above. The rivers can erode only when the water level falls or the land rises, so that this feature can be exposed, and that's a lot of height. It's very unlikely that change would have happened. Otherwise, rivers can't erode below the base level. And finally, page 69, we have the turbidity current theory by Davis, Tangier, Smith, Daly, Buchanan. It talks about, look at the 9th, 10th line, it says, these undercurrents bring fine material in suspension, and so they are called turbidity currents. The high density of these currents due to suspended sediments with them forces them to flow seawards, and they erode the shelves to form submarine canyons. So very fine sediments, they become dense, they push towards the margins, and as they flow, as they fall, they erode. They scour out the edges, forming the canyons. Okay, so this takes care of the concept more or less. So again, try writing an answer on this. I have given you the format more or less. You can have a description, a few lines, have a diagram of this kind here. Okay, maybe plot them or give some table here if you can with a map. Then you have the theory 1, theory 2, theory 3, and so on. And a conclusion, okay, around how this is part of the diversity of the basin of the ocean floor, and the deposits that they bring becomes parts of the ocean floor accumulations. So you can watch this couple of times, make your notes, and see if you can attempt this short note. Let the answer not be more than 2 pages. So 1.5, 2 pages, a typical 10, 15 mark question should be good enough for this. Thank you.